So to move on, so this, I think there are there 4 pages or 2 pages? 2. Okay. So these 2 pages, we're gonna, no, there's 4, well, back 2 pages front, back. These all have to do with the idea of area under the curve, and what it means is that, and what area under the curve means in different contexts. So looking at this, I think I may have you skip this first part. This first part is more of a mathematical thing. So to at least help you on this setup, let's talk about what this is. I have a function. I'm trying to find the area under the curve from where to where? From 0 to pi, which is going to be 0 to pi right here. So I'm trying to find the area under the curve from 0 to pi. So using the notation we just learned, what would that look like? Let's write that right here. Pi up here. Well, you can put one of two things. You can write f of x dx. So one, you could write this, and this would be good because I know what you're talking about. You could also put in the function, so you could write 0 to pi of sine x dx. They mean the same thing. So what we're going to do, what I wanted to do for number 1 is we're going to approximate the area under the curve using rectangles, left endpoint rectangles. But we're going to write the work without calculating it, because these calculations would give us very not fun numbers, because you have to plug in and use sine. Sometimes those numbers aren't that nice. So the area, or this, is going to be approximated. What would this setup be? How many rectangles do I make? 4. So let's do one rectangle. Let's do the first rectangle.
0.
It's so tiny, because you're using the left endpoint, that you end up getting what height? 0. So technically this would be 0 plus, what would the next rectangle be? Sine of pi over 4.
Can't you just do 2 rectangles and multiply by 2?
You could, because this is symmetric. Let's just, well, actually, let's just do it this way and then try your method after, okay? So sine of pi over 4, do I have to multiply by the base?
No, because it's 1.
Are you sure the base is 1? What is the base? So I do have to multiply by pi over... Here, let me zoom in. Maybe you guys can't see it. It's pi over 4. From here, one of these units is only pi over 4. because this from 0 to here is pi over 4. So this is pi over 4, pi over 4. So it stops at pi over 2, but you started at pi over 4. So each of these intervals are going to be pi over 4 as the base. Plus, then I go to the left-hand side and I go over. So Jesse, do you see now that you're not going to be able to just double it?
Yes.
Now, here's the thing. Jesse is not entirely incorrect. His method would be good as far as just approximating the area under the curve with any method. But this question is asking for a left endpoint. So you have to use left endpoints for every rectangle. And then this would be sine of pi over 2 times pi over 4 plus, and then the last one, can we simplify this without a calculator?
Yes.
Why?
I don't know.
Unit
Sine
circle?
pi squared.
We know sine of pi over 4. What is sine pi over 4?
Square 2 square root of 2. No. Square root of 2 over 2.
Over 2, yes.
Yeah.
So 0 plus, I'm not going to write that again. So this is square root of 2 over 2 times pi over 4 plus, what's sine of pi over 2?
1.
1.
Sine pi over 4.
This will wake up.
Sine 3 pi over 4, which is like square root of 2 over 2.
Again.
This will wake up.
Melissa, did you fall asleep? Do we need to stamp your forehead?
It's not farting. It's a
Party!
Chocolate Wednesday.
Party.
Keep going, mister.
Remember, you are a trailblazer.
Okay.
Nah, that's cool.
So do you understand this method, this process? Now here's the thing, a lot of times the AP test asks you to do this type of work in two situations. In free response, they oftentimes ask you to write the setup without calculating it. So something very similar to what we just did, because they want to see if you can do the process. They don't really care about the numbers. They also have approximations on the multiple choice part, and they have different setups that are, one's correct, but then the other ones have like, they forget the pi over 4 to trick you, or they put they put pi over 2 to trick you. They do a lot of little things, but it's recognizing which setup is correct. So let's ask this question. Without using your calculator, how could you find 0 to pi over 2 exactly?
Ooh, I know. Well, isn't it the same thing where you just
Plug in 0 and then go back. So we never can have that one like S, big S, you have to span it out. This value plus this value plus that value. So that's gonna be your setup, right?
Yeah, that would be the setup. Okay, so let's so do you remember last year in physics when we talked about area under the curve? a little bit.
Yeah.
We're not in business no more.
Yeah, I know. No more.
Anymore.
We ain't busy no more.
Are we gonna take business in college?
Oh yeah, were we have to take business in college?
Do you?
So you
Choose
wanna
what
major in
science
them?
classes.
Because I'm not gonna want.
It's usually you get to pick. Some majors encourage you to take certain sciences, or they'll say our majors usually take this or this, or this science helps you in the major more than this science. And then some colleges, they're big enough where they can offer like let's say you're doing business, they'll offer a business. Well, not a business science, but like physics for business majors or something like that. Okay, because I took, when I took chemistry in college, I took chemistry for engineers. Chem 121.
Was it hard, mister?
Chem? Yeah, Chem was tough. Okay, so let's try part 8. Let's try this problem. Car is moving with increasing velocity. I think it's next page. Or no? Yes. So let's plot these few points that we have. 0, 20. So plot the rest of those points.